Hello, everybody. Welcome back. And welcome for the first time to those of you who are joining us for the first time. Welcome to today's webinar, Building Diagnostics and Analysis with guest instructor Randy Williams. I'm Rachel Wagner, one of your co-hosts.
Oh, yeah. And I'm Josh Vandenberg, one of the other co-hosts.
This 1-hour webinar is part of Green New Deal Housing's Train the Trainers project. It is essentially a class for our T3 cohort who are participating in 12 classes and supporting activities throughout this project over the course of 6 months. We'd like to thank the University of Minnesota Regional Sustainable Development Partnership, the Energy Conservatory, and Minnesota Power for making the T3 project possible. T3 cohort members are encouraged to ask questions and join the conversation as we go. We ask that guests remain muted and view the webinar. Please use the raise your hand function if you're familiar with that. If you have a question, please stay muted unless you're engaged in the conversation. You can also type questions into the chat. Our guest today is Randy Williams. Randy started his construction career in the mid-1990s, installing electrical, plumbing, and HVAC systems with his brother. In the early 2000s, his family branched into building and renovating homes. And by 2005, Randy was working full-time as a general contractor. He furthered his education in 2009, becoming an energy auditor. Today, Randy works with other contractors, homeowners, and utilities, performing energy audits and building investigations. He is also a contributing author to several trade publications and regularly teaches building science principles at various events. You can follow Randy on Instagram at northernbuiltpro and on his blog, northernbuilt.pro. Please join me today in welcoming Randy. We are so excited to have him with us.
Thanks for having me. It'll be fun.
All right. So we're going to ask you some questions, but we're also hoping it just sort of turns this into a larger and broader conversation. You know, your bio touches on the breadth of your experience over 30 years. Can you tell us a little bit more about your career trajectory?
Sure. I've been really fortunate in being able to experience so many facets of the construction industry. You know, a lot of people get tied into one stream of the trades, and I've been able to experience almost a lot of them. Everything from I've done concrete work, foundation work, all the way to the roof, and then everything in between. So, just having that understanding of how things work together. I mean, I think you're going to be covering houses as a system coming up in a future presentation. That's really how I think about things. I really think about the next trade and how the work that we're doing is affecting the other people or the house itself. Kind of fun. It's as I've started to learn building science, 2009 again, when I first started that the energy auditing end of my training, that opened my eye up to the building science side of things. I had a little bit of understanding. I mean, you always, as you're a contractor, as you're a builder, or even an electrician, you see problems. Maybe you don't identify what they are, but as I've learned the building science end of the trades, it's really opened my eyes to how things work, how the things that we do affect the house. It's fascinating.
That's awesome. Randy, one of our questions that we had for you is that if you could describe what your process is when you're conducting audits. What is that process, and what do you do, as kind of your day-to-day there? If you were to show up and had an audit, this afternoon or whatever, what would that look like?
Yep. So my process actually starts, the majority of the energy audits are, a lot of them are what I refer to as a assessment, an energy assessment, To me, an energy assessment is an audit without testing. You know, I'm not doing a blower door test. You know, the company that I perform a lot of these for pays for a limited service. If the customer feels that they want more testing, they have to pay for it themselves. So a lot of the stuff I do is just the basic. It's me looking at what's going on in the house and making my best estimate of what's going on. But how I start is I'm given let's see here. Can you see that? How about now? Did it pop up? It's
Yes,
there? Okay.
you're screen sharing. Thank you.
Okay. Yep. So how I start is I'm given this, this is an actual bill that I get for somebody. That's 12 months of consumption. And I'm going to analyze that. This one happens to be a pretty nasty one. If you look at consumption, which is it'd be the usage column there that you know, the average I think in Minnesota is about 750 kilowatts. The month of December, it looks like they were maybe 10,000 or even a little bit more kilowatts between their everything that's going on in that house. So that's how I start. You know, just kind of where do they line up? Is it what do I think is the problem? This one I had no idea until I got to the site. You know, it was pretty hard to jog anything out of those really high numbers.
Hey, Randy,
Yeah,
was this house an electrically heated house? Oh, it says
was
off-peak heating, dual fuel.
it had
Oh,
yep, it had two separate electric systems in it. And this house was a log home. So it had, yeah, several strikes against it. The systems weren't working right. The house was built in, I think it was the early 90s, and that rate 62 off-peak heating, that is actually an in-floor cable system. So they had cables underneath the concrete. Back then, for some reason, somebody thought it would be a good idea if we didn't put any insulation underneath the system. So you're heating to China basically. It's just you're heating down and up and sideways, and nothing to contain or, you know, direct the heat to where it needs to be. So that was part of the reason for the issue of this house. The other rate, that dual 60 or that rate 65 dual fuel, that was a ETS, electric thermal storage furnace. And that thing would not shut off in the coldest months. Matter of fact, the homeowner complained that they could not get the main level of the floor, main level of the house up past, I think it was 60 degrees when it was cold outside. So it was a very uncomfortable house to be in besides. Oh, yeah, it was a fun one. And that was one that I did not do a blower door test on. The homeowner wanted to keep it as affordable as he could, and I probably could have given him a lot more information had I had the opportunity to do a test. So when I get to the house, this is another one. This is what is not the one that I had the consumption on. This is a different one. But when I get to the house, the first thing I'm looking at is what's going on. You know, what's going on with this outside of the house. Of course, this one's log, and I don't know. Most of the time, I have no idea what I'm walking into. So I get out of the truck and I scratch my head and I say, "Oh man, another log house." And I can move forward from there. This one's unique in that it's got a gambrel roof on top of the log house. You know, the roof design complicates air sealing and some of the other stuff that might be happening in the house. I'm looking at snow amounts on the roof. You know, there isn't much on there. Did it blow off? Did it get raked off? Did it melt off? I don't see any ice dams, which is good. You know, some of the stuff I'm looking at. Windows, I'm looking at those. Are they all intact? Do they look like they're in good condition? Does the overall house look like it's in good condition? What's the foundation? What's poking out of the roof? What are the shingles? All this stuff is, I'm thinking about it before I even walk to the door to knock on the door to let the person know I'm there. It's all the stuff that I'm kind of taking a peek at to try to figure out what might be going on. Once I get in the house, I have a questionnaire. I sit down for, well, depending on the house and the client, 15 minutes to half an hour, just asking questions. And the questions range from how many people live in the house, how many bedrooms, the building age. I'm looking at the foundation, asking questions about the foundation. We're looking at the windows and doors. Two of the most important questions I ask is, are you comfortable? What areas in the house aren't you happy to be in when it's really hot or really cold out? The other one I think is really important is, do you notice any humidity in the windows on the wintertime? That's going to give me an indication. Is the house tight? Is it, if they're all dry and it's a 2-pane window, there's a chance that this house has got a fairly good natural air exchange rate that maybe we want to talk about. Other things I'm looking at is do I have access to the attic? How do I get in the basement? Do I have to go outside? I'm looking at the stuff that's in the house, all the equipment, the stuff in the kitchen, heating and cooling equipment, electrical equipment. Through the years, what I've discovered is there's always only 3 problems with the house. There's a problem with the house, there's a problem with the equipment in the house, or there's a problem with the people living in the house. It's always one of those 3, or oftentimes it's a combination of them. So once I get through this kind of walkthrough, we dig into the house a little bit more. I might be in the attic. We're looking around the basement. We're looking at equipment. We're walking around the outside just to see what's going on. And of course, if we're doing other testing, then I'm setting up gear, making measurements. If I'm doing a blower door test, of course, I got to have volume. Depending on the house, I may even measure the area of the exposed surfaces, the area of the house, the walls, roof, floor, if I need that metric. Most of the times I'm just looking at the air change rate and the CFM moving through the house if I am doing a blower door test. And of course, if there's a blower door test, then there's thermal imaging, as long as I have a differential temperature between inside and outside. We're also, one of the things that I'm keying in on is indoor air quality. It's something that more recently the equipment that we can use to monitor indoor air is getting more affordable, a little more reliable. There's different gear out. For instance, I've got gear out now that I can measure radon, and of course the quality of the air, the CO2, fine particulates, VOCs. I think that's a very important thing that gets added to my service. One other thing is, if I do have combustion appliances, I'm depending on how far we're going in with the testing. I want to try to make sure, at least a visual inspection, to make sure that we don't have a problem with bad things coming in the house. I do have a CO monitor, a wearable CO monitor, and I'll kick that on if I feel that I'll have to go outside and make sure it gets to fresh air to balance itself, and then go inside and check. But I don't always turn that on. But if there's combustion air and I think there's a problem, yeah, that's going on. I'm going to test to make sure that we don't have a problem with the people living in the house, where they're not getting sick. One of the other things that you kind of really pay attention to is, as you're walking in the house, your senses, the sense of smell. Is it hot? Does it feel muggy? Is it cold? That I was in a house today that as soon as I walked in the house, I could smell wood smoke. And I'm questioning why is that? Well, I happen to have 2 fireplaces. The main floor fireplace was never used. The one in the basement was used. And I think there might have been some stack effect or something going on, where some of the odors were coming back in from the burnt logs that happen to be sitting in the fireplace. It was an older house, older fireplaces. So, but your senses have a lot to do with what might be happening in the house. You always have to pay attention to that. I'm sure I'm missing a whole bunch. I mean, when you're dealing with a homeowner, you get drug in a lot of different directions. You don't know what they want to talk about or what's important to them. The other thing I found out is that a lot of the times the homeowners already know what the problem is. They might not recognize it, but they know there's a problem. It's just a matter of me teasing it out of them or putting two and two together, and then all of a sudden the light goes off in their head, and they, oh yeah, now I understand. You know, a lot of what I end up doing is homeowner education. You know, just telling them that, hey, this is the issue. This is why the issue is, and might be a way to correct it. So that's my process, I guess, in a nutshell.
Do you find yourself doing an energy audit and a building and a building investigation that like how do you differentiate and especially let's say if you're doing it through the utility?
Yeah. So I don't know until I get there, unless the homeowner tells me something. Hey, we have a humidity issue. For instance, I had one of those last week. We have moisture on our windows all winter. Can you help with that? And I don't think a lot of people realize that that's something that a well-versed energy auditor can figure out. It's not, it's not rocket science. It's just a matter of figuring out where's the moisture source coming from. Why is it high? Repeat your question again.
Well, I'm wondering if it's so. This is I was hoping we might go into this direction because and I think a number of our questions touch on this because of course building science is part of both the energy auditing process, but also building investigations. And I don't know if this is the right moment to talk about it, but maybe it is, where, we started with a question for you. Well, what's your energy auditing process like? And I'm going to make an assumption that that most of what you call an energy audit is somehow a homeowner signed up for this, maybe through the utility, or the utility is paying for it. Is that fair to say?
The majority of them, yes.
Okay, so if the majority of them are paying for the utility, is it also fair to say that the utility has contracted with you because they're hoping you're going to produce a report that's going to make recommendations for the homeowner to save energy?
That's part of it, yes.
Well, is that part of what the utility wants, or does the utility want more than that?
No, the utility really doesn't put any expectations on me as far as the recommendations I give. But part of the energy audit, how this works for the utility, is that they are issued a credit. So for instance, while I'm there, I'm installing or giving a homeowner products that might save them energy, LED light bulbs or a low flow shower, aerators, stuff like that, and they're able to take a credit based on what they estimate. And I don't know who came up with these estimations, but the estimated yearly kilowatt savings. Obviously some of them aren't saving that much. If somebody's already got a low flow shower head in and they're just replacing this one, obviously they're not saving any, or not saving much anyways. But the utility is allowed to take that credit. That credit accounts for, all the utilities have to reduce consumption so much a year, a small percentage, and this helps them achieve that. And of course, if I see an opportunity to make an improvement for them, for instance, in the way of let's say we have a regular storage electric water heater, for instance. Those happen to be one of the more expensive electrical devices in a house, $30 to $40 a month, depending on the amount of people. What if we can put that on a program, where the power company controls, they turn it on and off, heat the water at specific times. It helps them kind of maintain their load, so they're not peaking at times. They can shed their peak times a little bit. And in exchange of that, the customer gets a reduced rate for allowing the power company to turn the water heater on and off. Is that good? Well, I think so. The customer's saving money. They've already got electric, or maybe they want to switch from a gas. Maybe they have a natural, or just a natural drafting gas appliance in the house, which we know isn't the best. We would like to move to either a power vent or a even better a electric water heater, or a air source heat pump water heater. That would be ideal. So if I can move them in that direction, if it's the right fit for them, I will suggest that. If it's not the right fit for them, if I know that it's not, I'm not going to suggest it. I'm thinking of the customer. That's on me. I want to make it right for them.
Well, that sounds really exciting. I mean, it seems like every customer you're going to run into is just going to be a little bit of a unique situation that you just have to be really adaptable when you come through that door because you don't know what hand you're dealt.
Exactly. Yeah.
And how fun on a daily basis to, have to think creatively like that.
Yeah. The very first, or I think it was the third energy audit I ever did. This was in 2009. I just about quit. I had to go to a house. The homeowner it was a 70s build. It was all electric baseboard heat. And then they had I remember they had a high electric bill. You walked in the basement, you could hardly breathe. It stunk so bad. Apparently the owner's brother was a trapper and he was skinning stuff in the basement and it really didn't smell very good. And as I'm walking through, the homeowner, he's apologizing, sorry, for the way it smells. But he's pointing out that I have to make sure I don't step on the dog droppings as I'm going into the house. And we get into the base. I came into the basement, and there's a little potbelly stove that the homeowner's just trying to do whatever he can to keep his house warm. And he had used it. This was probably April when I was there. He had used all the firewood he had. So what he did is he somehow managed to get all his brother's girly magazines, and that's what he was using to heat the house. I'm going, is this going to be the norm? Is this what I'm going to see every time I'm on one of these? Thankfully, it's not. That was a pretty unique situation, but yeah, it was a little shocking.
I think once you say, now I've seen it all, you've just opened the door for something new.
Yeah, exactly.
And shocking to come at you.
Yeah.
Yeah. You touched on the next question just a little bit already. And maybe, if there's more you add to this, it would be awesome. But just building science specifically, how does that inform and impact the work that you do? How does that fit in?
It's critical. I mean, without it, I remember early in my career as an energy auditor, I was called to a house. This was probably 2011, and it was a slab on grade house, and they had a very high humidity issue. And I could, not for the life of me, I could not figure out where their humidity was coming from. Back at that point in my career, I just didn't know the right places to look or the right questions to ask or whatever it was. I could not figure it out. They had an air exchanger, it was running. Was it running correctly? I don't know. There was no testing. But as I've been furthering my career and getting a better understanding of building science, that really starts opening your eyes to what you have to do, what the questions to ask, the testings that have to be performed. And you don't really know, it's hard if you were a new energy auditor just starting. It's really hard to gain that experience. It just takes time. There's no other way around it. Either that or you got to have a really good teacher, someone that you follow around. I didn't have that. I got certified through it was the Dunwoody Institute in 2009 as an energy auditor. Passed the test. Applied for a job I walked into Lake Country Power and asked them if they had any openings. I said, sure, you're hired on the spot. So I had nobody to really ask starting off. It was just a learn as you go. And thankfully they managed to keep me on. I'm now their only energy auditor. I think at the time there were like 4 of us. Their last one finally retired. Other than me, retired. I think last year. I took over the Ely area now, so I go all the way up to Ely for some of these. But they managed to keep me going, as a side job to my regular career. And what a valuable experience learning what things not to do. When I was a contractor, well, I don't want to do that. That didn't work. Let's try a different way. Just having the opportunity to see all this stuff. It's been fun. Yeah.
I think a follow-up or sort of to this building science question you alluded to, which is you didn't have maybe the greatest instruction, and you also weren't going back to an office full of building scientists. So what did you do then? And what do you do now? Or maybe share a little bit about the trajectory of where you go for information. What were you doing then? When you're researching or trying to answer a question, if you haven't figured out the solution to something that is puzzling, I think that an answer to that would just be really, really helpful for this whole cohort.
So how I started, back in 2009, of course, the internet was there. But I didn't have the, I guess, the reach of all where I should be looking at things back then. You know, Green Building Advisor was brand new. I didn't know about it. I didn't know about that until probably 2013 or something before I finally stumbled across that and realized what it was. So I had to go back to books those early days, and I went back to my earliest. That's actually my training manual from 2009.
I know that book. I'm sure you've taught it, Josh.
Everyone should have that book.
Yep, I agree. If you're interested in I mean, start, you know, after being involved in this class, start with this one. Start with that. And then move to that residential energy.
Yeah, hold that up again for a moment for everybody to see. We have not, or not this one.
The other one.
Yeah,
the Saturn one. Whoops, there we go. The residential energy. Yeah.
Yep. And I think there's a few editions. Matter of fact, I have another one of these around someplace. It was an earlier edition that I had. So I have two someplace. I don't know where it's at. The other book. Lstiburek, you know, that's pretty, and that's was more for me as a builder, but the building and the building science, energy auditing for me was going hand in hand at that time. So I was learning not only for my career as a general contractor, but also, you know, the building science and energy auditing. I was getting information from that. As my career moved forward a little bit more, you start networking with people. You know, I have a bucket list. It's a building science bucket list of people that I'd like to meet, places I'd like to visit, and conferences that I really would like to attend. The number one for me was always building science summer camp. It was the big one because it's the hardest one to get into. It was, and I managed to get in this year. You know, and I'm going to go every year now. Now that I had that experience, I can cross that one off, but it's still valuable to me to attend that every year. But going to JLC, for instance, in 2017, I think was my first year, or not JLC, IBS, the International Builder Show, and being able to meet some of the people, Matt Reisinger, for instance, for those that don't know him, he's a founder of the Build Show Network. Great resource for me now. If I don't have a lot of time to watch all the videos, but every once in a while I'll run into something that maybe I find interesting, I'll hit. But back then, he was kind of an influence on me to try to, maybe I could do something that he was doing, you know, to spread the things that I've learned. You know, he started back in 2009, back YouTube. He was a YouTuber, and it kind of grew on him. It took him a long time to get it to grow, but now he's kind of a monster in the industry. But other people being able to, you know, sit in a presentation with Joe Lstiburek and John Straub, if they were at IBS, I happened to see both of them at one time or another. Being able to meet people that work for Building Science Corporation. Peter Yost, for instance, I met at IBS a few years ago. So being able to just network is the big thing, I guess. Reaching out to people to create friendships. And it kind of what comes around goes around. You know, they're all of a sudden somebody's going to be asking you a question. Hey, you posted about this on Instagram a little while ago. How did you approach that? Or I may ask them a question as well. So yeah, that network is, I think, key.
Does networking happen at all through your blog? And I realized we didn't set up a question about your blog, but I want to mention it because I don't remember if I found your blog first or read an article by you first, but maybe you want to talk about when you started the blog and what prompted you to do it. Because I found it and I was like, who is this guy? This is really cool. Because the only time I'd ever seen folks really discussing building science issues and just putting it out there for everyone else to read was on Building Science Corporation's website, which was a whole company out east. And then here I stumbled onto this thing called Northern Built Pro and learned it was in Minnesota. So please share what made you do that, when it started, who finds you, if you engage with folks. I would love to hear if that's kind of a community as well.
It is. I started in 2018, I believe. And just a way for I wanted to expose people to what I was seeing, you know, as an energy auditor, doing a few building investigations I was doing at that point. I could see a lot of problems that I felt needed to be shared. It morphed a little bit, you know, once the pandemic hit. I submitted an article to Green Building Advisor, and Brian Pontanillo at the time was the editor, and he took it and ran with it. He published it. You know, the first one I didn't get paid for it. I donated it. I was happy for it to be out there. But then I think they gave me an idea for a second article, and I wrote it and I published, or I forwarded it to them, and it got published, and it kind of snowballed from there. I think I've got 60 articles on Green Building Advisor now that have been published. In between, you know, I think it was 2021 spring, I submitted an article to Fine Home Building, which was it was a garage article, attached condition garages, which I was seeing some issues with. I wrote an article on that, and they edited it like crazy because they had to, you know, I was written for a northern climate, and they had to include the South. So they edited and added air conditioning and all this other stuff that I just don't experience up here. I made the article better, but you know, it wasn't all of me. And in that same issue, they published an article I wrote I think it was in August, on blower door testing. It was kind of a comprehensive article. And it was October that they called me and said, Randy, we've got two articles we're going to publish in the December issue, and you're going to get the cover. And I just about fell over. I ended up on the cover of it as well. And that kind of really pushed both me and my blog forward a little bit. All of a sudden I had a little bit more recognition. The blog now, I get about 6,000 people on it a month, which is, you know, it's pretty good. I'm happy with it. I was talking to Allison Bales. I've got a new goal. He gets about 10,000 people a day on his. So I don't know if I'll ever get that high. I'm not a physicist, a PhD physicist that can make things really interesting, but yeah, maybe it'll grow a little bit more. I'd be happy with that. It's free. I don't make any money on the blog. As a matter of fact, it costs me money. I have to pay for the hosting and the internet that I have to connect to it, and everything that goes along with it. The web address, I have a yearly fee on that I have to pay. So it ends. I don't make anything on it, but I enjoy it. You know, it's nice to be able to write now and be able to publish it in another location and then republish it on my blog. That way, I just keep it going.
So I love that you said you sort of started the blog because you were seeing all these things that you wanted people to know about. So what do you wish every tradesperson understood about building science and building performance?
I really wish that they understood what they are doing to the house affects not only the house itself, but the other trades, the other portions of everything interacts, you know. I can remember, this was been back 2000 or 1998 maybe. We were working for a contractor, and he came up to me and he said, we got to put some outside lights on. Where would you like them? And we said, well, we need one right there. He took his hammer and just busted a hole with the head of his hammer through the OSB. There you go. There's your hole. And I went, okay, you know, I didn't know any better. That's fine. I'll mounted that box there and moved on, you know. We never did that. We always drill a hole. It was easier, you know, but I don't think he realized that. Well, I know he didn't realize what he just did to the air control layer or to the water control layer. You know, the different barriers of the house that we don't want to have water dripping in or air moving through. So you know, having them understand that the stuff that they do will affect the house. I actually gave because I'm a licensed electrician, I have to take continuing education every year. So last year we were in continuing ed, state of Minnesota, electrical. I talked the electrical teacher to give me 15 minutes and teach electricians about air control layers. I don't think any of them listened. Half of them probably sleeping, but hopefully a few of them. I actually had a couple of them come up to me after the class and say, "Hey, we never thought about that. That's glad you let us know." So hopefully I reached somebody. Yeah.
Yeah, and planting those seeds I mean, that's probably where most of us have come from, right? That there were these seeds planted along the way for us, and you know, and then we pursue that as something, you know, because it's valuable, because we want our buildings to work, all of those things.
Yeah.
So what a great thing. We have another question here too, and I appreciate what you said earlier too about the building science knowledge taking time, and what you also said about networking, and you know, that's one of the hopes of what we're doing here is we're creating a network for folks, and we're giving people a springboard into it that you and I didn't have, and that, you know, Rachel didn't have, and hopefully that's, you know, something that ushers that along even faster, which is you know, super exciting to be a part of, for sure. You know, one of the things with the Green New Deal housing training is you know, addressing the issues of you know, the environmental impacts and the climate change issues that we have going on. How does that recognition, at least for you, impact the work that you do? Or, you know, how, you know, does that fit into the picture for, you know, sort of your day-to-day work that you do?
You know, I actually asked a question to Joe Lstiburek last year at IBS, or a couple of years ago at IBS. My comment was, and I had seen the 2021 energy code and the change in the climate zone map, and how Wisconsin now doesn't have any climate zone 7 according to the map. Minnesota shifted a little bit. You know, the climate zone shifted 6, shifted a little bit further north. We have climate zone 5 now, which we didn't have in the previous map. I asked them about that. I said, you know, should we be maybe thinking about our construction techniques, or you know, poly. We're for instance poly. We're a poly state. I don't know how about Wisconsin. I'm sure that there's some of the stuff up north that's still being used.
Yeah.
That has such a detrimental effect in warm climates. It's not used anymore in, for instance, Kansas City. Is that climate eventually going to get to us? He kind of brushed me off a little bit. He said, I don't think I'd worry about it. I don't agree with him. I think that is something that we should be thinking about. You know, it's what happens if 50 years from now we're in climate zone 5. You know, we're not cooling. I mean, we're cooling a lot more, and we've got poly on a wall that we're building today. That I don't think that's good for the house. I think we need to think about different ways to build these structures to make them safer, make them longer lasting. Hopefully we're building houses so that they don't last just 50 years or 70 years or even 100 years. I'd like to see our structures last 200 years. And I think that all needs to be taken into account. I think we need to be thinking about climate change and how we can address our houses or structures to better suit what might be coming in the future.
Yeah, right. I mean, I think that longevity, if we're going to be using these resources and materials for a building, we should be good stewards of those resources and materials, for sure.
I agree. I agree.
100%.
We have about 20 more minutes in the webinar, and Josh and I have lots of questions for you, Randy, but I want to make sure that that our cohort participants also recognize. If there are questions or things you want to hear more about, please don't be shy. Or if you are shy and you want to write it in the chat, we'll do our best to convey what you'd like to know. One question I want to make sure we get to, and it gets a lot of attention, but maybe not in this way, is that our society, and this I think builds on the climate change question as well, because I think that there are an awful lot of folks who believe that we are going to just technologically get our way out of climate change, and that's a whole nother question that we can dive into if there's time. But that is to say, our society is pretty tech and tool focused, as if we can solve all our problems if we just have the right tool. And the right tool is important, but we would love to hear you, Randy, talk a little bit about the limits of tools, what else you rely upon, why it matters, and maybe also like how and where tools are the most helpful in this way to you, and which ones.
Okay. So tools are just that. They collect data, but somebody still has to understand what the tool is telling us, or or maybe when the tool is not telling us the right information. So I got a couple of that's not one. Thermal imaging. It's one of my favorite tools. I enjoy using it. But when we look at this picture, what's it telling us? It doesn't scream out and say, hey, there's an issue. We have to interpret what's going on. Can you see? Everybody could see the thermal image?
Not yet.
It's not there.
There was a little bit of a lag last time, so maybe there's just a bit of a lag, but.
Sorry, I'm muted. I think you have to start your share again because I had stopped it, Randy.
Oh, okay.
See if you can.
Better?
Yep.
Okay.
Thank you.
So that thermal imaging, what's that photo telling us? It's giving us some information, but we have to interpret, right? If we look at that pane of glass on the left, I've run into a rash of these in the last couple of years for some reason, but that's a patio door, sliding patio door, and the gas has escaped from the panel on the left, right? Those two panes have pushed just a little bit closer together, or pulled a little bit too closer together, and there's more heat moving through that, and that is kind of what that's showing us. It's colder in the center of the glass for that. I remember the first time I saw it, I didn't know what that was. It's taken me a while to interpret what the thermal imaging is telling me. How about this one? What's that telling us? That's pretty basic. I see that all the time when we're doing blower door testing. But someone that isn't trained in thermal imaging or in building science, it's pretty colors. It's actually air being drug across a surface. That cold air is cooling the surface down. Those rays are fingers. We have to interpret that. We have to understand. The tool is great. It's giving us the information, but somebody's got to interpret it. How about this one? This is actually last week. This was a brand new one I ran into. Air source heat pump. Center thermal imaging is actually the picture to the right is what I saw first. A little bit of water dripping out of the siding. Why? This was a day it was right around freezing. It wasn't raining. There's a big overhang on this house. Why is there water dripping up that high out of the siding? I don't know why the siding is pulled back that way, but whatever. It made it easier for me to see what was going on. That thermal imaging told us. I wouldn't have known that without thermal imaging. It's that penetration for the line set for that air source heat pump wasn't sealed, and there's warm air containing some moisture coming out, hitting a cold siding and condensing, and the water follows the siding and drips down. It's a process of interpreting what you're seeing. So this is back to my my indoor air quality monitoring. and things that I'm doing. This is my house. So I've got it's called an AirThings monitor that includes radon testing. But what's it really telling us? You know, you have to understand, why are my VOCs high? It's telling me that they're fair, but they're elevated a little bit. Not nothing I'm concerned about. What are VOCs? You know, you have to do that research. How about CO2s? It says it's fair again. It could be lower. Is that dangerous? Am I worried about it? What's the outside level of CO2? It's all information that you need. The tool is great, but you have to understand what it's telling you. I happen to have the radon, another radon detector. See that? It's a radon eye. This is a separate radon detector that I've only had for a couple of weeks. This is the data that I took the screenshot from the previous, that one. We have 2.6 picoliters per curie, picocuries per liter of radon. We switch over to this one, we got 2.14. That's a little bit less. Why? You know, is it one of the monitors? Probably. These aren't you know, industrial grade monitors where I spent thousands and thousands of dollars to get accurate data. It's close enough. I'm seeing trends. You know, you can see the graph on the right. That's actually the last 2 weeks or so. That's what the radon's been doing in my house for the past 2 weeks. It's bouncing. Why? Why does that bounce like that? Interpret the data. Mark Rosenbaum actually turned me on to that radon eye. Is a building scientist and engineer in New England that building science summer camp. He gave a presentation on this, and he kind of gave us a little bit of insight why radon does what it does. Fascinating class. That is available too. If you go to the buildingscience.com website, they have all the presentations from this year's building science, and Mark Rosenbaum's is up. You can watch that. This is the last one. This is the monitor that I use on energy audits. It's the only one that I take with me as of now. That radon eye will eventually come with me, but for now, this is what I'm doing. This is actually the house that I visited today. Again, same thing. What's bad? What's good? It's giving me a number for RH. You know, relative humidity is 40% good. I don't know. Is it 30 below? Probably not good at 30 below. Is it 60? Fine at 60. You know, you have to be able to interpret or understand what the data is telling. This is one of my favorite ones. Yeah. Oh, did you lose it?
No, we're looking at it.
Oh, okay. Okay.
Right there.
That's why we said,
What's that tell? That's my neighbor's house. You know, you know, 10 years ago or 15 years ago, when they were doing this work, I probably wouldn't have taken a picture. I wouldn't know what I was looking at. What's it telling you, Josh? What's that telling us? What's that photo? Can you describe it?
There's probably some moisture laden air that goes through that assembly every year and collects.
Yep.
And now we get to see the evidence of it now that the first condensing surface has been taken off.
Yep. That matter of fact, the first condensing surface was just that aluminum or steel siding. There was no cladding on this or sheathing. That was the assembly.
Holy cow. And
I'd imagine if I pulled that insulation out away from the top, I would probably have a bunch of dirty stuff up high too on the inside. You know, air moving through, it wants to rise up and find a place on the ceiling or near the ceiling to escape. Stack effect, possibly. It could be wind driven too. But yeah, it's understanding what you're seeing, understanding how to interpret not only the data, but the like a photo like this, what's happening. So
okay, let's stay on this for a moment though.
Yeah. I'm
also seeing a pretty decent job of bat insulation installation. Thought we should point that out.
Yeah.
And I don't see much evidence of moisture long-term or buildup on the studs or the rim. Do you, Josh and Randy? Did you see?
I did not. I didn't jump the fence to go take the insulation out to see if there was any in it.
Maybe some evidence by the meter there just below that, but that's probably from outside, not
it's just a little bit.
So
ironically, with no sheathing, all of that air that was passing through if it was condensing on the back of the aluminum, it was probably just running down and making its way out. And looks like they had sort of a metal whatever's protecting the foundation is metal.
Yep. Yep.
So
That's a crawl space. That's actually a manufactured home from the
so
70s.
oh, interesting. So weirdly, some of what was poorly done from an air sealing standpoint potentially could have increased the durability of the actual structure and maybe allow him to do something now that continues that durability. Would you think that's fair to say?
Well, what they did, I didn't introduce myself. I should have, to these people, to let them know that what I do, just to give them some tips. That the carpenter decided that they sheeted the whole thing, and then they strapped it with 2x material, so it was like a 2x2, and then they put foam insulation between. So they completely changed the dynamics of how the house works. You know, they've still got a thermal bridge. They probably made the air sealing a little bit better, tighter. There's no air. I know there's no air exchanger. There's no mechanical ventilation in here. So I don't know how they're controlling humidity in the wintertime. If it is a problem, maybe it's not a problem. But there's definitely things that I'm curious about. You know, what's it going to look like in another 20 years? Is it going to be as good as it is now? You know, the way that it was at this picture. I don't know. Yeah. Fun stuff. When you're a nerd, you enjoy the nerdy stuff. Yeah.
Interesting. Are you still sharing, or should we pull back?
I can pull that back. Or if you can, it might be easier. Okay.
I can do that while Josh, you want to think about your next question or two, or see if there's one in the chat?
Yeah,
a few more minutes.
Would love to not dominate all of the questions. So if there's anybody in the group here who has a question for Randy that fits with, you know, the work that Randy's been doing, I'd love to hear your questions too. Otherwise, I know Rachel and we could continue asking questions as we go, but anybody out there have anything burning questions they'd like to ask?
All right, there'll be time later.
Okay, good. So I guess that, you know, one of the things that I think is apparent, at least in my work too, is that the building performance industry has been changing over the last decade. And I don't know if you've seen that change at all either, you know, since you've been in there. Do you believe it's changing the way that it needs to be at this point? Or you know, if you look at the change that you've seen, what does that look like for kind of the future moving forward?
Yeah, it really varies so much. The crowd that I associate with the most, a lot of them have their own they're contractors, they're general contractors. A lot of them have their own blower door. They've now got to the point where they're testing their own houses at different points of the construction process to make sure things are progressing the way they want to. But that's in the crowd that you know, if you're Instagram, for instance, Instagram has got this really great little following in the construction industry where there's a lot of really good high-end, well, not even high-end, but there's regular builders that have embraced the efficiencies in the building science to make sure that they're doing things correctly, making their buildings last longer. And that's the group that I grabbed onto fairly early, 2018, as I was starting my blog. If you get to the production builders, I think it depends. There are some production builders that do not want to have callbacks, and those are the ones that are concentrating on the efficiencies or making the houses better. There are another group of them that are just trying to build as cheap as they can. They're trying to build code minimum, and their trades aren't maybe performing some of the duties that they need to. For instance, I run into this every once in a while on some of the jobs that I end up doing. I might be at a blower door test and actually see a neighbor's house that's under construction, and I usually trespass and go check things out, see how things are going. But I'll see a lot of, for instance, holes for line sets, air conditioning or air source heat pump line sets that are coming out the exterior wall. Who's sealing those? You know, they're open when I'm there. The house wrap is up, maybe part of the siding is going up, and these holes are open. That's a problem. That's going to be a problem down the road at some point. Probably after warranty is off. You know, it'll be 20 years down the road, all of a sudden siding's falling off in that area, and somebody's got to come in and fix something. But so I think it varies so much. Like I said, with who's paying attention. But I think overall the industry is getting better. I think we are making improvements. I think we do need, this class is a great example, to be able to teach people that there's other ways to do things other than the way that the building owner has been doing it for the last 30 years. You know, the construction company owner, I hear that a lot. We've been doing this for 30 years. It's worked. Still, there's better ways to do it. So,
I think we
yeah,
have
I wish there was more programs like this, more classes, and more people had accessibility to them. You know, could access them. Yeah.
Well, part of doing the online versions of things and webinars and then recording it as this one is being recorded is so that we can put more of that content up onto the web, make it free, available all the time, and then hopefully get the word out. So please help us with that, getting the word out part.
Right.
We do have a question from one of our cohort members, and they ask, what is the most formative experience you have had as an energy auditor beyond the poop in the basement story? Maybe a more recent formative.
You know, when I get into some of the big complicated houses, matter of fact, I'm going to share my screen. I'm going to show you one. This isn't one that I did an energy audit on. This was actually a complex. There's a series of houses on a single piece of property. It's family owned. This one is quite unique.
You're going to have to share again.
Yep. Do you see that?
Not yet.
Now?
Here we go.
Okay.
Yes.
So
for real?
That is one of the houses next to a log cabin that I was working on. How do you even build something like that? You know, all those round turrets, and I know I've been in that house. The foundation's round, and it's ICF. How did they make a round ICF? You know, this number one, this took a lot of talent. This is a company that really knew how to build unique structures. But is it right? You know, the very bottom, that little building that's kind of on its own at the bottom, that's a swimming pool in it. You know, at least there's an air chamber between, you know, kind of an airlock between the main house and the swimming pool area, but it is all kind of connected. The upper right portion is a big attached garage. There's a big fireplace in there. It's gorgeous. It's very beautiful in there, but I don't think it performs that good. It can't. I don't know how you build a house that complicated. It just makes all the details that much more. And then for me to go in and try to figure out if there was an issue that they needed determined, I'd be there for days trying to, you know, just to measure the volume of it to do a blower door test so I can get an accurate reading on information. Yeah, that would be an ugly one. Those black things on the top on the roof, those are actually copper. It's a copper. It's a, what do they call that? That's that arced roof on the round part of the roof. It's a crazy house.
Randy, I don't think you could have closed with a better example of why we need more people in this field. I mean, this kind of complicated, there's more and more of these.
Yeah, it's amazing.
Yep.
Wow. Well, we are at time. An hour flew by pretty fast, as we expected it might. I want to say thank you on behalf of Green New Deal Housing and our cohort of folks. And I'm just really glad that you are in the field that you're in, and you're in the location that you're in. We are extremely fortunate to have you here in the Upper Midwest with us.
Thank you. Thank you.